The next thing we'll take a look at is a fancy thing called sigma notation. Sigma notation is just a shorthand notation for that you'd like to have the sum of a series, and it can be used for arithmetic or geometric series. We'll still have a series of terms that are added together. We'll still have a sum, and we'll still need to use this formula to find the nth term, and we'll still need to use this formula to find the sum. But we're going to have some shorthand notation, and the shorthand notation, the gist of it is this. There we go, that's better. So the gist of it is this thing, which is called sigma. It's the Greek letter sigma. It's the capital Greek letter sigma. Hopefully you saw the smaller, the lowercase Greek letter sigma earlier when we looked at standard deviation. This is the capital Greek letter sigma. And what we do is we say, let's say that we want to add up a number of items. Well, first of all, we'll start off with, we'll define a little variable, I'll call it k for now, and we'll set it equal to some number like, let's set it equal to 3. That'll be the starting point for the series of interest for us. And then we'll say, let's have k go out to, let's have it go out to 5 to keep things simple. And then we'll go ahead and we'll make up the nth term for this guy. So the nth term in this case will be something like 2k minus 1. So this is sigma notation. K is going to be the variable that we use to evaluate each term. The 3 will be the index of the term, and the 5 will be the last index of the term. By the way, from the other stuff that we looked at, n is typically known as the index of the term. So this is the index of the term. And even though this is actually a number 4 or 3 or 2 or 1, those are also indexes. N just stands for the index if we don't know exactly what it is. So in this case, our index goes from 3 to 5. So we will be able to figure out how many terms we're interested in this way. So I'm using a temporary variable called m in order to figure out the total number of terms that I'm interested in. In this case, I take the top number, 5, I subtract the bottom number, 3, and then I always add 1. 1 I always add. And when I do that, I get this number 3, which will be the total number of terms. Now in this case it's pretty easy because I could have just counted 3, 4, 5. That would have shown me there's 3 terms. But if I have many terms, it might be easier just to do the math here, and then we'll use this in one of these formulas up here. So let's go ahead and let's go 2k minus 1. So our first term is going to be 2 times 3 minus 1. So I want to remind you, this guy right here, this whole thing, that's a sub 1. That's our first term. And you're always going to find your first term by taking this, which, by the way, let me be clear, this guy here, that's our nth term. And you might recall that the nth term is always abbreviated a sub n. So our a sub n is this guy. And to get our first term, we just take 3, plunk it into k, and then evaluate. And let's go on. So if I want to get the second term, I'll just add 1 to the 3, and I'll keep going until I get to 5. So we'll go 2 times 4 minus 1. That is our a sub 2. And let's go ahead and we'll add one more. This will be 2 times 5 minus 1. And I get that by substituting this k with this 5. So I now have my a sub 1, my a sub 2, and my a sub 3. There's my 3 terms, And as I predicted earlier, I knew that I was going to have 3 terms because of my little calculation here. Now, if I go and evaluate those and add them together, I'll get the sum of this whole sigma thing. Let's give it a try. Okay, so the sum of 2k minus 1, starting at 3 and going up to 5, is going to be, this is 6 minus 1, that's 5, plus 2 times 4 minus 1. And really, I should have put brackets around. Let me go ahead and throw some brackets in there for safety purposes. Should have put parentheses around this, because all this has to be evaluated before we ever add to the next term. This will be 8 minus 1, that's 7, plus 10 minus 1, that's 9, and that gets us 12 plus 9 is 21. So this whole thing here, this sum, let me see if I can do this for you. This sigma notation tells us compute the sum of this series, and the result that we get is this, 21. That's what the result will be. Yay. Now, we're going to try looking at this in another fancy way. We're going to use the sum formula to compute, and we'll try some bigger numbers. So, if we want to find the sum of this guy without writing out all the individual terms, what we'll do is we'll use the sum formula. And in the sum formula, we say S sub n. In this case, what we're going to put in for n is we're going to put this guy right here. We're going to put this number because it's the total number of terms that we're interested in, which is 3. It is, by the way, we're not using this guy down there. That's not what we're using in this case. It's just coincidence they're the same number. Now, since we do put a 3 in here in the formula, that means we need to put a 3 on top of the 2. And then a sub 1, we will have to calculate that. That is going to be 6 minus 1, that's 5. And then plus a sub n, that will be a sub 3, which again, we will have to, well, we'll have to calculate a sub 3. Now, it turns out a sub 3, or the a of this term right here, it's always going to be that number. I mean, it's always going to be this guy right here. It's always going to be this. It's always going to be take this number and put it in for k and then evaluate. So let's take a look and let's see what we can do here. So this will be equal to 3 divided by 2 times 5 plus a sub 3, which is 10 minus 1, or 9. So to get this guy, to get the 5, we're always going to use a sub 1. That'll always get us the 5. And to get a sub 1, we're always just going to take this expression here and fill in this number for our k. Now, to get this guy right here, to get this guy, we're always going to use the very last a, whatever it is. And the way we get that very last a is we take this guy and we take this number and we fill it in. And in this case, it gets us 2 times 5 minus 1, and that gets us 9. Okay, so let's go ahead and see if we get the same sum as what we got before. So S sub 3 equals 3 over 2 times, don't forget that's 14 over 1. And remember, we can cancel, so we don't need a calculator for this. 14 and 2 cancels, gets us 7. 7 times 3 is 21. And if you recall from manually working it out, that's the result we got. Now, the best thing to do at this point is to try an example where you're going to find the nth term and you're going to find the sum for an arithmetic series.